Hello and welcome to this session, where I'm going to learn about create the Springboot Microservice Docker Image step by step. How to create the runnable Springboot Microservice Docker Image. How to enhance Docker image security. How to reduce Docker image file size. How to use environment variable in Dockerfile. How to create a runnable Springboot Microservice Docker Image. In previous session, I created a runnable Springboot Microservice jar file. The jar file was used to create a Springboot Microservice Docker Image. When containers start, one thread needs to run and listening user request. The Docker file has two major parts. Copy jar file from local to image. Run the jar file. Let's go through the Docker file to get detail. There are commands from label add, expose, entry point. From command declare parent image. The image is OpenJDK 8. Label command add metadata to image. The format is key value pair. Version information, author information, description for the image. The add command copy demo -0.0.1 snapshot jar to image my microservice folder and change the jar name to demo.jar. Expose command introduce the image listener port. The expose is only declares the port but doesn't open port. The Java opened the listener port on 99999. Entry point command is able to start a thread while Java minor jar. The jar file is in my microservice folder. Jar name is demo.jar. And then build a Docker image. Open my terminal. The MVN folder was created last session. The folder has source code and jar file under the target folder, and the runnable jar file under the target folder. Create a Dockerfile. Build image. The image name is a microservice. Version tag is v1. Build context current folder. Next, check image detail. Let me open the Docker file to compare the image detail and the Dockerfile command. This is parent information from the label search. Add labels information in the Docker image. There's three entries equal to label command input. Expose port 9999 default is TCP. Also, the protocol is able to change UDP. Entry point information from entry point command input. Clean screen. Start container. The name is microservice v1. Run detach mode in the background. -im is important. It's able to automatically delete container after the container stop. Port mapping from a local box 9999 to container port 99999. Image name. Check container status. The container microservice v1 is running. Check log. Springboot startup. Port listener information. check jar file. My microservice folder is created by add command. Add command. Copy the local demo 0.0.1.snapshot jar to container and change the name demo.jar. Next step, test two APIs. For the testing, I need to find the container IP. Docker network inspect bridge. All the container is without a specified network will automatically attach to default bridge network. Container name microservice v1, IP is 172.17.0.3. Other way, I can use VS Code Docker plugin, get the IP address, open networks, select bridge, and then click inspect. There's the same information. Add user. Find the user list. The Springboot container work as our expectations. Stop container. I had a runnable Springboot Microservice Docker Image. How to enhance Docker Image security? I have a to-do list. Update OS packages. Create a user to run Java manager command. Do not use as a router user. Replace add with copy, because copy is only copy local file. Add is able to download the file from network, so there's a risk. Man is a middle attack. Go Dockerfile and see the change. There are commands. Run, copy, user, workdir, cmd. Copy command. Copy demo 0.0.1 snapshot jar from local target folder to image my microserver folder and the name change to demo.jar. Run command is run in shell, which by default is select bin/shell on Linux or cmd on Windows. Update the package information. Add a user and the user group. The standard Linux command. The user and switch to the new user microservice. Demo.jar location. Export, no change. Same as before, value. Same as entrance as start point in image. Create a Docker file. There's the image we created before. Build a Docker image. Build successfully. There are total 12 steps in the build process. Each step maps to one Dockerfile command. Further steps from parent image. Next steps, add metadata to the Docker image. Latest steps, cmd command. Equal to latest command in the Docker file. If I build again, what happened? Since there's no change, all the steps using cache. And then start a container. Check Springboot log. Start successfully. verified jar file. When I log in, the default folder is my microservices, because when the image starts up, the work folder is my microservice. There's a demo jar file. Next step, test two APIs. Add user, get user list. API running successfully. Stop container. Haskell Dockerfile Learner is a security tool. It can verify Dockerfile and give you build best practice recommendation on the Dockerfile. How to use it? I can use the image to scan and analyze my Dockerfile. There is command docker container run -rm -i. Container name is headland. The image and the tag. Only one parameter is my Dockerfile. Running. There is a recommendation how to enhance my Dockerfile security. There are 4 items is homework for you. If you have any questions, let me know. Now I had a runnable and secure Springboot Microservice Docker Image. How to enhance Docker container performance? Best practice is reduce Docker image size. There are 2 things I can do. Use small parent image and reduce Docker image layer. Go Dockerfile and see the change. The parent's image changed to OpenJDK 8 GRE Slim. Because I don't need to compare the Java code, I have a jar file already. Second change. One run command create one image layer. Merge run command to one run command. There is only one run command. Previous, I have 5 run commands. 5 run commands will create 5 layers. One command, only one layer. Create a Docker image. Build Docker image. OpenJDK 8 GRE Slim is a new parent image. The image ID 8C3C, etc. Also, we can find the image ID in build process. First step, from image, same image ID. This ID equal to OpenJDK 8 GRE Slim ID. Run containers. Check log. Running successfully. I'll skip other steps because the same. No difference. Finally, let me check the image size. Microservice v2 image size is 578 megabytes. Microservice v3 image size is 250. Size reduced 50% since I used a small parent image and reduced Docker image layer. I had a runnable, secure, and smooth-side Springboot Microservice Docker image. How to make a stable Docker file. Use environment variable replace hard-code items. How to do it? Read build arguments and pass arguments to the environment variable. Go to the Dockerfile. New commands arg env. Arg command define a variable that user can pass it arg command define a variable that user can pass it build time and support default value. Input source jar file name. There's default value. If Dockerfile if Docker build command cannot find build time parameter, input source jar name. Dockerfile use default value. env command. Introduction set the environment variables. Other command can use the dollar brackets and the variable name to use the environment variable. Other command is same as before. Create a Docker file. And then build a Docker image, use default value. Build successfully. Start container, check default microservice folder. Should be my microservice. Because Dockerfile uses the default value of agreement. Stop container. Next, try to change app location folder. The new parameter, minor build minor arg. Input folder name is test. In the build time, I set up a parameter. Let's try. Run a container to verify my input app folder name. Application folder name change from my macros to test. That means input app folder name change in the build time. I had a runnable, secure, small size, and parameterization Springboot Microservice Docker Image. I hope that all very useful and interesting to you. I will meet you in next episode of Docker.